Welcome to Areas of Parallelograms and Triangles. I'm Mr. Pi the Math Guy, and the title of today's lesson really lets you in on what we're going to study today. We're going to study areas of parallelograms. Cool thing to understand is that rectangles are parallelograms, so we're going to see in the next slide how the area of a parallelogram is the same as the area of a rectangle. Here we have the two theorems, the theorem for the area of a rectangle. The area of a rectangle is the product of its base and height. Here we have area is equal to base times height, or area is equal to b times h. You may see in other textbooks, some textbooks might be calling this length times width instead of base times height. The textbook I work out of uses base and height. The base is typically the longer side, the height is the shorter side. Here we have the theorem, the area of parallelograms. The area of a parallelogram is the product of the base and the corresponding height. Notice the difference in how that's worded. The reason I want to point that out to you, between up here, where it's just the product of the base and the height, and down here where it's the product of the base and the corresponding height. If we take a look at this here, I have two parallelograms, and each parallelogram has two different heights. The areas will be the same, but there are two different heights depending on which side of parallel sides or pair of parallel sides you're using as the base. In this case here, we have the base being the shorter sides, and you can see here, here's the perpendicular distance between these bases. And one thing you want to note is that this height can be brought outside. You can visualize that being brought outside if we extend this base over. So the height of a parallelogram can be outside. As we can see over here, we can do the same thing when we're using the other pair of parallel sides. The height can be outside the parallelogram. So it can be inside the parallelogram and outside the parallelogram. It depends on how you're looking at it, but that height is the perpendicular distance between the two bases of a parallelogram. In example 1t, we are asked to find the area of the parallelogram. To do that, we need to remember the area formula, which is area is equal to the base times the height. And in this particular diagram, we have three numbers. We're told both bases. We're told that this base, the left and the right base, has a length of 10.5 meters. We're told here that this base, and well, the top base would have a length of 12 meters. What we're given is this height here, 8 meters. And what you have to understand is that this height, since it's perpendicular to this base, it's the height that corresponds to 12 meters. So to substitute in here, you would go 12 meters times its corresponding height, which is 8 meters. When you multiply that out, that gives 96 square meters. So the area of this parallelogram is 96 square meters. The key piece of information that you need to take away here is that you don't need to use this 10.5 because we don't know its corresponding height. Example 2t. We're told that a parallelogram has 9-inch and 18-inch sides. Let's put that in our diagram. So the shorter side is 9 inches and the longer side is 18 inches. The heights corresponding to the 9-inch base is 15 inches. Find the height corresponding to the 18-inch base. So we know the height corresponding to the 9-inch base is 15 inches. What we have to find is the height corresponding to the 18-inch base. So let me put that 18-inch base height in first. That's what we're being asked to find, is that height right there. What we're told is that the height of the 9-inch base, and watch how I draw this in. I'm going to extend this side of the parallelogram, and then I'm going to put in that height, and that height goes from this corner down to here so that it's perpendicular. And we know that that height is 15 inches. So if you really don't understand this diagram, here's another way to think about it. We know that the areas, either way we calculate it, should be equal to each other. So this amounts to an area is equal to an area kind of problem, where the area, when we calculate it 9 times 15, is going to have to be equal to the area when we calculate it 18 times h. So The area one way is 18 times h, the base times its corresponding height. That's what we're trying to find, that h. The other area is going to be 9 and 15. We know that because we're told that these two correspond to each other in the problem. The height corresponding to the 9-inch base is 15 inches. So we know that if we take the 9-inch base and multiply it by 15, it should be equal to the 18-inch base times its height. So it amounts to a pretty basic one-step equation. 18h I just bring down, and 9 times 15 is equal to 135. 9 times 5 is 45, put down the 5, carry the 4. 9 times 1 is 9, plus 4 is 13. Then we divide each side by 18. When we divide each side by 18, that gives us h is equal to, 18 goes into 135 7.5 times, or 7.5 times. So I know the height that corresponds to the 18-inch side is 7.5 centimeters. And it wouldn't be centimeters, it would be inches, because that's what we're working with in this problem. So it'd be 7.5 inches, not centimeters. We could have also set up a proportion to solve this problem. There's a lot of different ways you could attack problem number 2. Example 2t, key idea is that the area is equal to the area. Here we have another theorem, the area of a triangle. Now, you should be familiar with this theorem already. In fact, any of these theorems that we're talking about currently are really formulas that you've been taught in the past, at least some of them. And this is one you should be familiar with. The area of a triangle is half the product of a base and the corresponding height. In other words, A is equal to 1/2 times B times H, or the area is equal to 1/2 the base times the height. Now, in this particular diagram, we're told that this bottom side is the base. So then we multiply it by its corresponding height. Here's a key note. The base can be any side. The height is perpendicular to the corresponding base. The height is the length of the altitude. So really have two names for that. It's the altitude. Now what I want to that I need you to understand, not that I kind of need you to understand, I need you to understand that any of these sides could be the base. And when we change the base, we also then change the height. So as we move forward and we look at some problems involving the area of a triangle, it's going to be important for you to remember that any side can be the base and the height will change depending on which side is the base. In example 3t, we're told to find the area of triangle XYZ. So we can see here, triangle XYZ, we're given the lengths of two sides of that triangle and we're given the length of one of the altitudes. The idea is to figure out, when we use this area formula, area is equal to 1/2 the base times the height, which base to actually use, or what side is being used as the base. This should be pretty clear. In this case, here's the height, and it's perpendicular to side YZ. So YZ is acting as the base. So this is pretty straightforward. Area is equal to 1/2 the base, which in this case is 40 centimeters, times the height, which is 13 centimeters. Now we multiply it. I know a lot of my students, their gut reaction is to reach for a calculator, but let me explain how to do this quickly. 1/2 of 40 centimeters is 20 centimeters, and we need to multiply that by 13 centimeters. Now, instead of reaching for a calculator or writing your work out, you should be able to know, or you should know, that 2 times 13 is 26. And we just tack on a 0 because instead of multiplying by 2, we multiplied by 20. And that would give us 260 square centimeters for a final area of triangle XYZ. In example 4t, we're given a problem-solving situation. Let me read it for you. The front of a garage is a square 15 feet on each side with a triangular roof above the square. The height of the triangular roof is 10.6 feet. To the nearest 100, how much force is exerted by an 80-mile-per-hour wind blowing directly against the front of the garage? Use the formula F is equal to 4 thousandths times the area times the velocity squared. F, in this case, is the force exerted. So to use this formula that we're given, we have to calculate the area of the front of this garage. Now this is a compound figure. It's a square and it's a triangle. And to find the area of a compound figure, you have to find the area of the parts and add it together. So in this case, the area total of the garage is going to be equal to the area of the square plus the area of the triangle. So we got to find the area of the square and then the area of the triangle, add them together, then we can use our formula. So let's take a look at this. We break this down. The area of the square, that should be real easy. That's the length of any side squared because, well, the sides of a square are equal. So in this case, the area of the square is going to be 15 feet squared. And that should be one of those numbers you know, 15. You should know your squares 1 to 25. 15 squared is 225. So the area of the square is 225 feet squared. The area of the triangle, which we're studying in this lesson, is given by 1/2 the base times the height. And in this problem, we know the base is 15 feet. And we're told that the height is 10.6 feet. Now we can multiply this out. 1/2 of 10.6, well, 1/2 of 10.6 is 5.3. And then 5.3 times 15 gives us 79.5. And that would be feet squared also. So then we can put that here. We can label that. So then we add those two together to get the area total. And that would be 225 feet squared plus 79.5 feet squared. And when we add those together, that gives us 304.5 square feet. Now we can use the formula that we're given. We can use this formula here to calculate the force. The force is equal to 0.004 or 4 thousandths times the area times the velocity squared. So when we substitute in what we know and what we're given, 0.004 times the area, and that's this area right here, the area total, and we multiply that by the velocity squared, and the velocity is 80 miles per hour. And we can just simply run that through the calculator. I mean, we could do that by hand, but you know, there's no point in doing that by hand. It's more accurate and quicker to use a calculator for something like that. That comes out to be 7,795.2 feet. Or actually, that'd be pounds. This is how that force would be written. It would be in pounds. And it said to the nearest 100, not hundredths, but hundreds. So that'd be right there. So instead of 7,795.2 pounds, we'd write that as 78 pounds, 7,800 pounds. So there is some problem solving involving the area of a triangle and a square.